So there's a modern method, and that's one we're going to look at. So nothing against the Greeks, they're awesome. They came up with our C major scale, do, re, mi, fa, sol, la, ti, do. And if you notice, there's also what we call these black keys, the sharps and flats, these half steps. And notice how many black keys are there on a keyboard? There are what? 5 of them. So if there's 7 white keys, 8 to repeat yourself, and then there's 5 black keys, what's 7 plus 5? There are 12 keys in a full chromatic scale. So in Western music, it's all based on using these 12 notes to make a full scale. If you play like jazz or something, I think jazz only has, anyone in jazz band? I don't really know. I think it's 9 notes. Okay. And then, this is a little not kosher, but that's okay. You want to know how to play like fake Chinese music? Ha! Fake Asian music. Here we go. I'm Asian. You can make fun of your own people. All you do is a lot of Asian music is based on 5 notes. So just play the black keys. Check it out. Bong. Oh, very bad. Just mess with you guys. Sorry, there we go. And by the way, I'm actually not a music expert, so one of my friends is actually a music professor, and he saw one of my podcasts up, and he was like, actually, that's blues, not jazz. So sorry, I'm just trying to give you guys the idea. The magic is this. The second method, it's called the equally tempered scale. And the only magic number you need to know is the 12th root of 2, 2 to the 1/12th power. It's called the semitone ratio. It's that magic number, the 12th root of 2. What? What the heck is that? Well, first of all, we got to give credit to the guy who came up with this. He wrote all this fancy music during the Baroque era. Those of you in AP, you know there. His name is Johann Sebastian. Anybody know? Bach. Oh, I have it written down. There we go. So Bach not only was a great composer, he's actually kind of a mathematical musical genius. He came up with this, and it works perfect. Here's the idea. If you look at a full C major scale here, pull up my little virtual piano here. If I want to go from a do to a do, that's painful, right? How many steps are there to go from a C4 to a C5? Let's count them. We have to get all 12. Okay, ready? Here we go. So we're going to climb up 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many? 12. There are 12. There are 12 steps to go from one octave to another octave. So here's what's weird. This is the only number you need to know. You need to know this number right here, 2 to the 1/12th power. So why? Let me show you really quick. This is kind of weird, kind of mathematical, kind of nerdy, but really cool in terms of how it works. In order to go from a do to a do, like that, to double your octave, double your steps, your frequency rather, in 12 equal steps, there's only one number you can multiply by itself 12 times to get 2, to double. And that's 2 to the 1/12th power. What the heck is that? Okay, really quick. Let's make this easy. What's the square root of 4? It's just what? 2. You see that? How about this? What would the square root of 2 squared be? Oh, tricky. Square root of 2 squared. It would just be square root of 2, and then you square it. It's just 2. They cancel out. You see that? So the square root of 2 squared is just 2. So this is not a square root. This is a 12th root of 2. Huh? 12th root. What the heck is a 12th root of 2? It's actually, this is how you put it in your calculator. It's 2 caret 1/12. That's the magic number you need, which is 1.05946. This is the only number that if you multiply by itself 12 times, the 12th root of 2 to the 12th power will give you 2. That will double your frequency in 12 equal steps. So in other words, the only way you could take a scale and cut it into 12 steps and double your frequency is to multiply by this magic number, the 12th root of 2, 2 to the 1/12th power. In other words, that's like a lot of weird math to you, right? Let's try to unpack it for you. Get out your calculator. So let's go ahead and put in the magic number, 2 to the 1/12th power. So how do you do that? You would hit 2, not twice, just once. There we go. Then you want to hit that caret thingy. And then you have to put it in parentheses because of order of operation. This is the only number you need to know when it comes to music. Why? This is what's called a semitone ratio. It's a magic number, 1.05946. That will take you exactly, you can think of it like this, like a 12th of the way up. Okay, it's not really a 12th. It's the 12th root of 2. But think of it like that. You're taking a step up the scale there. And in fact, this is the only thing that you can multiply by itself 12 times to just get 2. What if I do this? What if I do 2 to the 1/12th power, which is what I just had. So actually I can just hit second answer. And what if I raise that to the 12th power? I multiply it by itself 12 times. We could do 1.05946 times 1.05946 times 1.05, etc. 12 times, but that's really annoying, right? So what if I raise to the 1/12th power to the 12th power? I'm just going to get what? Are you awake? Are you paying attention? What do you get? You just get what? 2. Thank you. You're awake. Yay. So how's this going to help us? Good question. In the end, nobody in real life really cares about calculating all these weird numbers. But in real life, you want to make music, right? And by the end of today, your goal is you're going to make one of these. But you're just making it out of cheapo straws. But in real life, people use cool stuff. I mean, Blue Man Group, they got... How many of you guys have seen Blue Man Group before? Fun show at the Bright Street Theater. One of those guys in the original Blue Man Group really knows their physics. You can't just cut pipes randomly and hope you get lucky. So in real life, it helps if you actually know how to calculate the exact resonant length to get that frequency, to get that sound. But in real life, people make instruments out of all sorts of stuff. Brass. Someone was telling me like their flute had like 80% real silver in there. I'm like, wow, that's nuts, right? Saxophones are expensive, fancy. Organ pipes, holy cow. I had a friend who went to the Naval Academy, and I got to go to his wedding. It was really cool, and they had like the swords and all that. And they were rebuilding the organ, the mammoth organ in the back of the Naval Academy. And that one, if you just cut a pipe randomly, it's probably going to be out of tune. That's like a multi-million-dollar mistake. So our goal today is to figure out how do you actually generate the tones of a full C major scale, and then more importantly, how would you cut the straws there to get the right length there. We're going to draw this keyboard here, and we're going to try to figure out how you need to cut straws to get a perfectly tuned instrument. That takes talent. That takes intelligence. You can do it. So what I want you to do is I want you to sketch from a C4, let's call this a C4, like a middle C, to a C5. That's a full octave. So you're just going to draw from here to like here on the keyboard is good enough. So all it is there are 1, 2, 3, 4, 5, 6, 7, 8 white keys in a full octave. 8 white keys. Do, re, mi, fa, sol, la, ti, do, 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 do. That was painful. And then there are 1, 2, 3, 4, 5. 5 black keys. You see that? And what's tricky is the 2 black keys are evenly spaced, but then you have what's called a half step from an E to an F, and then it continues there. So let's just go ahead and sketch that out. And I'm going to go ahead and label these. You don't have to be in music, but this would be a C, this would be a D, E. I guess technically we could continue. This is a 4. The 4 just means it's the 4th C up like on a piano keyboard. That's all. So C, D, E, F. People in music, help me out. What's next? G, A, B, and then it repeats itself. Next, here's what we're going to do. We're going to take the official frequency of a C4. It's kind of nerdy. You guys ready? It is 261.6 Hz. What does that mean? It's 261.6 hertz. So we're just doing a full octave from a C4 to a C5. Do, do. Very painful. Let's do the easy one. The trick is, how do you actually figure out what all those notes are? So the easiest one to figure out right away is a C5. How would I get a C5? You guys know what an octave is? If I go up a full octave, 8 white keys, an octave sounds nice because the frequencies are whole number multiples of each other. So how do I go from a C4 to a C5? I just do what? I just multiply by 2. So a C5 is 523.2 hertz. Now, the Greek way is you use these whole number ratios. There's nothing wrong with that. The problem with that is it actually doesn't work. As you get higher or lower on a keyboard, it actually gets out of tune. So the best way is the equally tempered scale. The magic number, let's write this down actually. The magic number, there we go, magic. It's called the semitone ratio, is the 12th root of 2. What the heck is that? It's not a square root, it's a 12th root. It's 2 to the 1/12th power. You enter into your calculator like that. That's the magic number. What does that mean? That means if you want to go up or down the scale, you multiply by that number. So for example, let's go ahead and do D4. How would I do D4? What I have to do is actually have to go from a C, I have to work my way up the scale. I got to go to a C sharp first. For every half step, I'm going to go up there. So all I got to do is I take 261.6 hertz. That's a C4. I'm going to multiply that by the magic number. What's the magic number? The semitone ratio, 2 to the 1/12th power. Man, that is like super nerdy. 2 to the 1/12th power. So when you do that, you get 277.16. Good enough. So a C sharp is 277.16. here's what I want you to do. You know what? Don't worry about units. We already got hertz on. You don't have to write it on for everyone. I want you to then work your way all the way up to the top. So how do you do that? All you're going to do is take whatever number you get, 261.6, multiply it by 2 to the 1/12th power. Then you get a what? A C sharp, right? How do you go from a C sharp to a D4? I'm going to take what I just got, which was what? 277.16, whatever, and I'm going to multiply that number by what? 2 to the, what's the magic number? How do I keep climbing? 2 to the 1/12th power. You see that? Find the rest of the frequencies. Try it. You should have gotten these crazy numbers. So notice, to climb from a C4 to a C5, a full octave, it takes 12 steps, right? So in the chromatic scale, the equally tempered scale, the only number you can multiply 12 times to get double, a frequency double, is the 12th root of 2. So now, here's where life gets fun. In the end, most people don't really care about all these weird, nerdy numbers. 261.6, that's crazy. That means you want to shake the air exactly 261.6 times a second. What you really want to know is how long should you cut each of these straws, right, to make it perfectly tuned. So here's the hard part. It really depends on, not too bad, right? If you have the type of material, the thickness of the straws. We got the cheapo jewel straw. It's going to change it. So I want to point out that your instrument will not be tuned to a real instrument, but it'll be tuned to itself. So arbitrarily, I'm just going to pick a length for you. I'm going to pick this first straw to be 16 centimeters. Why? Just because that tends to work out pretty good for most straws. So we're just going to say the first straw is 16 centimeters. You can record that right on your C4 there. That's going to be the length of your first straw in terms of the air pipe you're going to set up. So now we're going to figure out the easy one. There's one that's really easy to figure out. Which one's easy? Which one? The C what? The C5. And the reason why the C5 is easy is if I want it to shake twice as fast, then it has to be what? Half the length, because wavelength and frequency are inversely related to each other. If you have something with a long wavelength, it shakes really slow. Something with a small wavelength, it shakes really fast, right? So in order to get something to have twice the resonant frequency, it has to have half the wavelength. So the hard ones are all the ones in between. It's actually not that bad. Let me show you how this is going to work. If you look at the wave speed equation, velocity is wavelength times frequency. Velocity is the speed of sound in air. You cannot change the speed of sound in air. Air is the medium. You don't change the speed in a given medium. So the only thing that you can control is wavelength and frequency. You want to make wavelength to get different frequencies. So in other words, the wavelength is simply the velocity over the frequency. To get different frequencies, it's the inverse of the length. So in other words, if I want the C5 to be twice as high, it's half the length. So how about this? How would I get D4? How would I get D4? I'll make it mathematical, but really we're just using common sense here. I just take the length of my original pipe, I multiply it rather by the ratio of the frequency. So think about it. Should the D4, just use common sense, be longer or shorter? The second pipe, should it be longer or shorter than the first pipe? If I want to make my second straw one step up, it should be shorter. But how much shorter? It's going to be the ratio of the frequencies there. So all I got to do is I have to take my new frequency that I want to get and compare it to the original frequency. So why don't I call this my C4 to my D4. Think of it that way. So in other words, let me just get out my calculator. Let me just show you. All I'm going to do is I'm going to take 16 centimeters. That's the length of my original straw. And then multiply it by the ratio of the frequency change. So instead of it being 261.6 hertz, I'm going to divide it by 293.6 hertz because I want it to go higher. In fact, I want it to be 1/8 higher. 1/8 of the way up, it's a whole step up. So it's actually going to be 1/8 shorter is the way to think of it, is what it ends up being. So when I do that, I get like 14.3 centimeters. 14.3 centimeters. Let me help you with the next one. If I want to get my E4, then all I got to do is do the same thing, but instead of dividing by D4, I'm going to divide it by E4. So I'm going to get out my calculator and do the exact same thing. I'm going to do 16, but I'm going to multiply it this time by the ratio of my new frequency ratio there. So I'm going to divide that instead of by 293.6 by what? 329.6. In other words, I want to go 2 whole steps higher. We're skipping the black keys. We're not going to build the black keys. So I'm getting like 12.7 centimeters. What I want you to do now is take a couple more minutes, see if you can get the rest of the straws.